let's kick off. So good afternoon to everyone. It is my pleasure to open another weekly debate at Food for Sustainability Academy, and we continue to address the role of digital tools towards more sustainable farming practices. My name is Claudia Costa. I coordinate the Food for Sustainability Academy, which is supposedly to be a place for knowledge sharing, some discussions, and to make sure that we gather several ideas toward more sustainable food productions. And to make these sessions possible, I cannot go without acknowledging my wonderful colleagues, Rita Silva, our MA microbiologist, Daniela Fonseca, our PhD in sustainable chemistry, and Silvia Moreira, our PhD in food science. I just would also like to send a word of thanks to Cesar Neto, which is our digital specialist, and has also put a lot of efforts in making these sessions possible. So thank you all. And now turning to our journey of today, we will take you to look how digital technologies, particularly satellite image, can enhance sustainability. Our first speaker is Hidromod, which does farming and watershed scale models for more precision farming. We then take a quick flight to Azores to join Air Center and understand how satellites can drive and can be used towards more sustainable decisions at the farm level. And we'll finally land in Leuven, Belgium, to join Leuven University in precision farming livestock to hear about the state-of-the-art developments and the current challenges for moving images. Many thanks to our speakers, and I hope you enjoy our session. And just before we kick off, some house rules. Let me remind you that our webinars are recorded, so if you don't wish to appear, please remain with your cameras off. We definitely encourage your participation, and as usual, our webinars will take about 1.5 hours long. So I'll now just ask my team, Rita, to tell you where we can find the webinars. Daniela will then just let you know how you can take part, and Silvia will tell you where you can find more about the current projects from Food for Sustainability.
Sure, Claudia, thank you. Good afternoon, everyone. So all our webinars are on our website, and I will post the link in the chat where you can view them. So I wish you all enjoy today's conversations, and thank you. And I can
Thank you, Rita.
Daniela.
Thank you so much, Rita. So regarding today's webinar, questions are welcome. If you have any questions, you can go to the chat and write them down. Just make sure you write the name of the speaker to which the question is addressed first. These questions will be answered at the end of each speaker's presentations, and of course, if there's still time, at the end of the webinar. Thank you.
Okay, hi everyone, welcome to our webinar. If you want to know a little bit more about the Food for Sustainability projects, you just have to visit our website, foodforsustainability.org. I can place the link in the chat. You can also send an email directly to me with any questions you have, or to any other member of our team. Enjoy our session for today.
Thank you so much to everyone. So let's kick off as we always do. I will start by sharing my screen, and let me just press the right button, which is here on the full mode. Okay, can you see my screen? Okay,
yes,
great.
Yes.
Thank you. This time I also introduced to this background discussion a small provocation to our panel members, and this is just to keep the levels of adrenaline high. I hope you enjoy the challenge. And as we've been discussing, agriculture has gone through a series of revolutions. And these changes, they have very strong impacts and have actually driven efficiency, yields, and profitability to levels that were previously unattained. And the market forecasts for the next decade, they even suggest that the digital agriculture revolution at the scale will be the newest shift to ensure that the agriculture really meets the needs of the global population, as we all know, is supposed to reach 9 billion people by 2050. Furthermore, the United Nations, through their Sustainable Development Goals, also place a lot of hope in the digital agriculture to deliver economic benefits, social and cultural benefits, and of course, environmental benefits through the optimization of the resources to make sure that we are actually addressing our climate change. But yet, the digital transformation is still a challenge. On one hand, many digital adopters are what is called data rich and information poor. This is actually a term that was coined in 1983 by Peters and Waterman in their famous book In Search of Excellence, where they start to look for companies that were really collecting a lot of data, but were very poor in transforming that data into a competitive advantage for their organizations. And this was the so-called data overload. And for sure, agriculture is no exception. It's a very complex system that ranges from seed sowing to selling the products. So it depends on several factors, such as agriculture inputs, intercultural operations, climate conditions, ecosystems, and above all, consumers' behavior. So if we want to understand this complexity in the agriculture system, we really require a holistic approach. And what we can see in the range of digital agriculture is that several fields of science are needed to make this a reality. And we are talking about information science, environmental science, computer and software engineering, system science, GIS, GPS, remote sensing, virtual satellite imaging. So a lot of different fields that need to be integrated with what's actually happening on the ground in terms of soil, in terms of the climate, the environment, and all its surroundings. And in fact, we can see that gathering all this information is critical. And for example, just to cite the case of John Deere and these tractors that today they passively collect a host of data and information at the farm level, from soil pH to soil moisture. So we are actually dealing with a very complex and demanding system in terms of information. So if we have on one hand a lot of data, this means that this data needs to be integrated. And why do we need this integration? Because what is needed is that all the information that we are getting from the soils, from the crop, from the animals, and even from the management practice that are required, they need to be kind of materialized in one single decision that optimizes all these subsystems. And this is very challenging. The data is often gathered in several formats. You know, the sensors don't communicate. And let me just remind you what we have seen last week with the Farm Cloud, with their technology to enable these sensors to start communicate by breaking the protocols that the manufacturers are so keen to maintain. So that we do have various range of opportunities. But what we see is that nonetheless, the uptake of Farm 4.0 is still far from being a reality, particularly for most farmers. And we can see, for example, that the European Commission is placing a strong effort, for example, on the European Digital Innovation Hubs to press on for more digitalizations, and the focus is quite strong on the agriculture sector. So I take this quote from Bill Gates and Melinda Gates Foundation. Why are smallholders farmers not adopting digital services? And we can find here two main blocks of reasons, and one of them relates more to the disruptions that the rearrangements in terms of the digitalization will require in terms of agricultural labor, the expertise at the farms in terms of literacy and digital skills, and of course not forgetting the level of investment that we are talking here. And for me, probably a more fundamental issue, it becomes more at the cultural and social level of the digitalization. And studies have pointed that actually digitalization of agriculture might require a new definition of what farming is, and this will actually have an impact on the cultural fabric of the agriculture communities. For example, studies from 2016-2018 found evidence that the pressure to use emergent digital technologies is somehow mismatched with the expectations that farmers have about what farming is. One other evidence that we note is that there is a strong correlation between these intensive farms, which are high in technology and high on inputs, and the size of the farm. So kind of leading that digitalization is somehow only for the big ones. So this was my provocation to you. We still have a strong potential to spread the adoption and to cater for other digital needs in the market. For sure that we here at Food for Sustainability, we work to turn the digital a reality for every farmer, but we acknowledge that smaller farmers bear the most challenging task in this revolution. And is against this background of benefits and challenges of digitalization that I will now introduce you to our first speaker, Pedro Chambel. Let me just close this. Pedro, a quick introduction. So Pedro Chambel is an agriculture engineer. He's a master's in mechanical engineer and a PhD in environmental engineering at Hidromod here in Portugal. In more than 20-year professional experience, Pedro has specialized in two areas: farm scale and watershed scale modeling. He was the coordinator of AquaPath and AquaPath soil projects, from which it was possible to develop integrated approaches to the management of water quality and quantity by integrating basin models with satellite images. Following this, at Instituto Superior Técnico, he coordinated MyWater and GMosaic. GMosaic focused on the use of land use maps to estimate land use, evaluation of pressures on the water environment, while MyWater focus on integration of data from remote source from practical use by farmers. We really want to hear also about this, Pedro. Since 2009, Pedro started to collaborate with Hidromod, participating specifically in irrigation projects, flood control projects, and water management. Also in Hidromod, he started dedicating more time to projects relating to operational modeling and integration of data and models for the production of information. He's currently managing Aqua Farm project. Pedro, thank you so much. I will now handle the floor to you, and thank you for being here with us.
Thank you. Okay, so the title of my presentation will be Sustainability of Crop Production, Satellite Data and Soil Plant Air Models at Field and National Scale. So I would separate this presentation basically in two parts. One is the presentation of the digital tools that we want to mention that will help in the sustainability of agriculture, which is satellite data and soil plant air models, and the scales at which we are doing this, which is the field and national, regional, national scales. So our main goal is helping agriculture and stakeholders to get information on their fields, and what we are going to show you here is how to find these tools and the tools that we can present and that can be applied for this purpose. So this this diagram here mostly shows, let's say, the value chain in which we are. So there is these people working with equipment, with satellite antennas, equipment in the fields, many kind of monitoring devices, which it is not our area. We do not work with equipment, we work with virtually data that might be generated. We also don't work with generating data from satellites, which is the work of Copernicus and USGS, which are two examples of institutions generating data on satellite. We are here. We are basically getting this data on the equipment, on the data from the satellites, and we are doing crop monitoring and modeling applications using all this information, gathering it also with weather forecast models, in situ data. And all this information that we are generating, we are giving it to institutions, stakeholders that work with the farmers. IFAP, here an example of a company, Wise Crop, which provides services directly to the farmers, and EDIA, which in Portugal is it's the biggest irrigation, let's say, it's a company in Portugal, which has a reservoir of 4,000 hectometers of water and about 100,000 hectares of irrigated land and increasing. Okay, so all this information in the end that we are generating through a lot of institutions are getting to the farmers. So how are all these tools being used and can be used for the sustainable agriculture? So I just put here some diagrams I got from the internet, so nothing like a good image to show an idea. And so basically what these images show, so the one on the left, it shows what is called the Nexus water, not water, food and energy, which is, here it appears as nutrient material, which normally we call it food. What we can see here is that for us to get a sustainable environment, what we have to do is make sure that the water is used in the most efficient way. So we should produce the maximum of food with it, and we should expend less energy with it. And by combining all these three aspects of the production will allow us to make the more sustainable service. And of course, all this has to be seen also in this perspective on the graphic on the right, where for us to make something sustainable, we have to take into consideration the planet, the profit, and the people. And in the middle of this and the intersection of all this, we get to have something which is sustainable. Okay, going for the digital tools. So this is just, well, this is a mixture of presenting of our tools and the presenting of ourselves. So we work with many models. Of course, we like our own. It's our own. And we enjoy to use our things. So it was this model, it is called MOID, and it started being developed in Technico in the 80s. In the beginning, it was just, so MOID stands for Modelo Hidrodynamico. And in the 80s, it was a coastal area model. In the meantime, also Hidromod was born and came out from this group. And in the year 2000, MOID was born. So I came to the group in Technico. I started to develop the land part of the model, and since then it starts to be an agricultural model, MOID. So it has two components, MOID water for coastal waters and MOID land for inland waters. And at the same time, AquaSafe was born in the 20s, in 2000s. AquaSafe was just our way of making these models useful and to make it operational, meaning to get to everyday life of the companies. And so this AquaSafe, this MOID land, everything was turning to this project, Aquafarm and WaterSense, that are ongoing projects that where we basically join soil plant term models and make them operational for different users. In the case of WaterSense, is an European project for Australia, where we are doing this for users in Australia, and Aquafarm for users here in Portugal. Going back to the satellites, we are using mostly as a satellite. So satellites that are being developed by ESA are a bunch. So we are focusing here on the Copernicus satellites, namely the Sentinel-2 and Sentinel-1, which have different, they have the version A and B, and and soon they will have the version C and D. And basically what it means is that we have some sensors on the top of the atmosphere gathering us a lot of data that we want people to use. So one of the things that we have right now running for IFAP is a national scale service where we are gathering all the data for these tiles of Sentinel-2. The contract we have right now with them that as a result of this Aquafarm project is for the year 2021 and 2022, and it will be renewed for the next years. And this service is at the national territory, and it basically represents an aggregation of all this information into the 4 million parcels that the IFAP has of Portugal. So every subsidies in Portugal are delivered at the parcel scale, and so they have to know all the information at each parcel. And this system is being used by IFAP to implement the CAP, by namely regarding automatic identification of each crop at each one of the parcels, and the subsidies will depend on this detection. This has been done in the past year for rice and tomato, and you can see information on the internet. There is some guides where IFAP explains what they are doing, and in fact they are sending information to farmers telling them, please provide me more information because I don't think you have tomato there, and so you are not entitled to this subsidy. And this, in the end, this service ends in a mobile app where they have to take photographs of their field if there is any doubts to prove that in fact they have tomato there. Tomato and rice, that's where this is being tested, though it is being running already for the entire country and for all the crops. This is an example of what is this crop detection. So this is an example that we are doing for Australia, where we are basically trying to see our capacity to detect the kind of crops. And as we can see, the crops there are mostly cotton and sorghum, canola, and as we can see, we have this F-score is mostly above 0.8, except canola. and we can see that we have a good detection capacity of the crops. And you can see here on the right the signals that we are reading and that we are smoothing. Because of clouds, there are some interferences, and based on all this analysis, we are getting the possibility of knowing which crop is where using artificial intelligence, basically random forest algorithms. This is an example of soil plant air models that we are using at the farm scale, and here we can see results at the pixel scale. So using Moidland model, we can see here on the bottom left soil moisture, you can see the variability in the field. So the water varies in the field, mostly because of soil characteristics, because of topography. And so that's what you are seeing here on the bottom left. So the time is going by and the soil moisture is varying also according with the precipitation. And you can see this point here, you can see the results of soil moisture at this point. So we can know, we can predict what is the soil moisture because we have a weather forecast model associated with the model, and we are doing this at an operational mode. So we can provide this to the farmers. And here you can see a graph where you can see in depth and in time the evolution of soil moisture. You can see clearly the evaporation happening, the precipitation that is entering into the soil, and this kind of results give you a very accurate evolution of what is happening in terms of water in the field, which is very important for farmers to make sure that the plants are in hydric comfort. Here is an example here in Portugal for IDEA, where we are estimating not for one parcel with very detailed 10 meter resolution. Here we are just aggregating all the information and running a model for each one of the parcels instead of each one of the pixels. And so like this, we can have this regional result where we have the soil moisture at a regional scale, in this case in ADA, the south of Portugal. So you can see here the time going by. You can see as we get close to any kind of precipitation event, any kind of month with a lot of precipitation, we will have higher soil moisture. And as we say in Portugal, in April, there is a lot of water. And so you can see here when we arrive at April, this year, in fact, we had a lot of water, and so the parcels are quite wet, so they are more bluish, and so the water is more abundant in the soil. And because we had a winter that was quite dry, you can see that the parcels were quite dry at this time. Okay, so all this information then is being fed into a system, AquaSafe platform, where we are getting all this information. So we are gathering EU data, in situ data, we are getting models that we ran ourselves, like the soil plant air models, we are getting meteorological models, we are getting other modeling from outside, from Copernicus, GFS, USDA, and we are getting all this and we are putting this into this big infrastructure where in the end, what comes out, and this is the only thing that the user does want to know, which this piece here is, what are the reports that he can get, what is the business intelligence that he can get, what is the standard data sets that he can get. And so if you want to see what we are doing, so you can go to this aquafarmhidromod.com and you can sign up and you can see some data that you can already see that is available. An example which is not there, but it is that we produce also with our results is, for example, it's quite easy to use Excel files, which for a technician is very good because we can put all this information into a very simple Excel file where association of farmers can see what is happening in a big region in a very condensed periodic report that he receives in his email. If you go to Aquafarm, you can just sign up and you can use your Google account or here I'm already signed in, but you can use your Google account or whatever you have available, and you can see this Aquafarm demo project and you can see results. You can see how you can easily see in time the variation, for example, of NDVI, with some statistics. You can see the average for each one of the parcels. You can also see, for example, geographic data that you can just download and see. In this case, it is the detection of water, which is also very relevant for farmers to know the water available in the surface water. So you can see here the detection of water. And and so I think that with this, I finish my presentation. Thank you very much for listening. And and maybe
thank you so much, Pedro. That was very interesting and a great application. From what you have presented here, it seems that Hidromod is very geared towards bigger projects. You talked about the national scale, the regional scale, eventually the regional scale. But could this be implemented more on at a farm level for a single farmer?
Well, you can go, for example, to this Wise Crop, which is an application that is not ours, it's from our company, where you can go to also you can also see some demo farm they have, and you can see results on this vegetation index. That is a service that is provided by us to them, and so you can see on your own parcel, you can see results at the parcel scale. So this is made also for farmers to be able to use this information, and this is done by this company using our data. So we provide to them, and they provide to the farmers, and they explain to the farmers what they should do based on this information.
Mm-hmm. Do you have an idea of the profile of the farmers that are more ready to adopt this kind of support systems in their daily operations? So my question is sometimes, and I've started with this provocation really to you, that these look very, fancy and complex systems, and actually they are more geared towards the ones that are more digital prone already. Mm-hmm. So can you make this somehow more, do you find it that smaller farmers could use such system? What is your experience? Do you need a lot of education? Do you need to explain the demonstrations? How does it work?
Okay, so our baseline service, we are using NDVI at a big range, and this NDVI is the information that tells you how green your field is, and this is a quite straightforward information. Of course, there is a bunch of many other indicators, but this one is quite simple. And so you can, like with an application like this, any farmer that will have some kind of parcel here, you can just, next to him in his mobile phone or something, you can just show him that you can, maybe he cannot understand and maybe he cannot use all this information, or maybe he can, but he can already see in his parcel what is happening. If there is something, there is a line here, maybe he knows what it is, or maybe he does not even know because it's in the middle of the corn and he doesn't realize it is here. So you can show him this. So it's quite visual and easy to understand that there's something happening here. And if you move forward in time, you can eventually see if this is happening or not again. Mm-hmm. And you can, at the same time, sorry, I wanted to show, okay. And so you can see here in another period of development, you can see here other variations. Of course, this will be probably a winter crop or eventually no crop, but you can see variations, and you can, and I think this is quite easy to see, this graph gives you the average of this entire parcel. So if it gives you the average, it means that you have the possibility of making a simple calculation. So when he presses here, he knows that he can look at this graph and he can say, well, this year this was the way my corn was grown. It grown like this. And last year it was like this, and the other year was like this. And he can look at it, at the details, and he can try to see, comparing the different years. Just by comparing the different years, he can try to take some conclusions out of this. And this is, I would say, even if the farmer does not know anything, I think it is a very simple graph to show him. So this is time. This is how green how strong your crop was. And so you can see that there are some differences. You can see that your winter crop was more strong here than it was here. And maybe he already does not remember this. He does not know exactly how it was last year. But now here it is clear that this year it was stronger than this year, the winter crop. Maybe the summer crop was similar, but this one was different. So they can see clearly that there's this information stored that they can use somehow to make some management decisions. I think this is quite easy, straightforward, even for low.
It seems very straightforward, and it's very interesting. But in fact, I think we when we are out on the field, we kind of see that, when you put up a graph like this, if you're talking with a farmer, they just prefer to say something like, just put more water or put less water. Anyway, but Pedro, just let me come back to our initial conversation. We were talking about students and the role of universities, just because you were also professor for many years. What is the role of universities, or at least some educational institutions, in giving more information about how to use this type of tools, how to know how to interpret these graphs? Do you think is enough being done at university level for farmers, or there is still some more work to do to promote this digitalization?
Well, that is a very difficult question, because again, it all turns into sustainability, because I think that the people that are coming out of the university, they are in fact coming out with more and more, they are taking courses on data science. And for example, I'm right now co-orienting a student that is working on trying to manage these NDVIs and transform it to something closer to the farmer. And this guy, he was from, I don't know, I don't remember what he was taking, the course he was taking, but the course where he's doing his master, it's in data science, and he ended up by working with farming data, and he is quite skilled on this. So he learned in this science data course in ISCTE. It is, I think it is in ISCTE. Yeah, I should know this by heart, but he's. So he is skilled in data science, and so he looks at these graphs that I have just shown to you, and he is able to filter them. He is able to try to get some information out of it. So I would say that the universities are doing some work that is going to be useful for the farmers, data science work.
Mm-hmm. Fantastic. Thank you so much, Pedro. We have a question here from the audience, and Daniela is asking, your AquaSafe platform work in business intelligence and crisis management tools. Can you give an example of the kind of report or warnings that are provided by the system? Have you thought about developing carbon measurement apps? Another challenging question.
Carbon measuring
applications.
Okay. So about the first part. So in fact, we are using the system to generate alerts, and so we are Hidromod. So we work with water and models, and every information that can also help us to do our work with water, that we've been doing for 30 years. So we're at 30 years now. And we have many different systems that generate alerts. For and I think it was focusing on risks, and I think it was something related to what we are doing, warnings. So we have a system to, for example, to predict the flows for the Via Navegável do Douro, so the Douro navigation line, where they want to know what are the flows to be able to navigate the boats that go up the Douro River. They need to know to manage the flows, for example, for IFAP. We are generating these crop alerts, where basically the farmers, whenever there is a problem with something that was declared as something and it is something else, I would call this also. So this is also an alert that alerts IFAP to take action, and we have, and in fact we have many other alerts, but for other areas that are not as related with agriculture. So I don't think they are relevant here. But yes, alert is basically alert. An alert is basically a threshold that we put in the values that you are estimating, and that generates some kind of warning. And we are doing this for different areas. For the carbon, carbon is something that it is sketchy, but it's not an easy thing to do. In theory, we can do that. So we have models that predict the plant growth, that predict how much carbon it is being stored as the plant grows, but it is something that it is not easy to implement an operational tool to do. No, it's easy to implement a tool, but to validate it and to make sure that it is doing the right accounting. And so there is a lot of work that has to be done on the data. And we will have to have a project related with this and to put these tools working in that perspective. But there is a lot of work on measuring, and we'd like to collaborate with someone that will do the measurements to calibrate the system like that.
Yes, we have. Thank you, Pedro. We have already addressed the carbon challenges and the measure, and how we can actually we make sure that what we are measuring is really what's happening in the ground. And I'm sure that we'll have projects here at Food for Sustainability. We are also looking into carbon. So Pedro, we will stay in touch. Thank you so much for your brilliant presentation and for your clarifications. I hope you can stay with us just for a little bit more. And I will now start by introducing our next speaker, Pedro Silva. Pedro is the CTO of Air Center Earth Observation Lab, as a lab at Azores. I don't know if you are in Azores right now. Yes, great, fantastic, beautiful place. Pedro holds a degree in aerospace engineering from Instituto Superior Técnico here in Portugal, with experience in space systems, project management, operations, commercial, technology transfer, and intellectual property management. He also has a special focus on industrial research and space engineering project management for ESA and the European Commission, including space missions. Pedro was involved in several engineering and product development activities for Earth observation systems for altimetry and biomass, as well as navigation systems components development for CubeSats and space launchers. Pedro has also been involved in the initial setup and deployment of an operational team for the marine surveillance UAV system, and is the author of patents that have successfully resulted in technology transfer to the automotive industry and startups. Pedro has an extensive experience in coordinating scientific and industrial partnerships. Pedro, it's a pleasure to have you here, and I now handle the floor to you to hear about your work at Air Center. Thank you so much.
Thank you. Thank you so much, Claudia. Very kind, and thank you for the for this introduction and for inviting the Air Center to be here and to present what we have been doing. So, my background is, as you said, aerospace engineering. So, what I will present here today is an example of the more than I would say right now 25 ongoing projects that we have in the Air Center. This one is very focused on agriculture and using Earth observation. And I will let you know, and I will share my screen. The project is called Sistema de Alerta Pithomyces. This is basically a big issue that we have in the Azores. In the Azores, for a very long time, there was a disease that is affecting and still affects nowadays the dairy production, the cows. In the Azores, there are about the same number of cows as there are people. So the cows are part of the economy. A very big, important part of the economy, and of course, when we started the Air Center, we had many meetings with different stakeholders, and one of the stakeholders here in the Azores government, they told us that this was a big issue. So, Pithomyces shirtarum is a problem that is a disease that affects basically a fungus that when it has the right humidity and temperature after these 72 hours, there is the production of the spores, which then will generate metabolism called sporidesmin. This is really not my background, but we have researchers that are part of the team which have identified this problem here in the University of Azores. And this will then create the disease, the pithomycotoxicosis, which is an intoxication in the cows, which will basically damage the livers of the cows and will make basically the cows with a lot of problems like sensitivity to the sun. They get in suffering. The milk production goes down to 5% or 10%, and it's not reversible. So basically, the cow is simply in a state that will not be able to produce anymore. So and this is a huge problem because it affects every year still today. A lot of cows in the different islands here in the Azores. The problem is mainly in the Azores. There are other regions of the world which the problem is also occurring, like in New Zealand. But there are also some reported cases of mainland continental Portugal. Of course, this is very rare happening there, but it's also a problem. So this is what the skin of the cow looks like. So there is, again, also the well-being of the animal is at stake here. So this is also a major concern. So this will, of course, result in economic losses, and this is a problem for society. So one of the measures that is today performed in a widespread mode is that at a specific time of the year, farmers start to give zinc in the mix of the food for the cow, and the zinc will basically protect the liver from this damaging, and it's a mechanism to prevent this major problem. The thing is that cows will have the zinc starting from a specific month, even if there is no information on the field that this is really happening. So they are kind of blind and they are just giving the zinc away. So this project SAP is a system that is creating a gateway of Internet of Things here in the Azores, which is starting in Terceira, then we'll go to São Miguel, and again. It's a project together with Unicol, which is the largest here in Terceira, a company that collects the milk and processes up to a certain stage the milk from the cows. And it also has a big support from the local regional veterinary lab, and also farmers. So this is done with all the stakeholders. And the objective here is basically to minimize significant milk losses, minimize animal suffering, of course, acquire new scientific knowledge, because this is a problem which we don't know yet how much it really affects the geography here in the different islands. And of course, there are application of this technology to other projects. And what we are doing now is the project started a couple of months ago, so we are really in the relatively early stage. But we are already implementing all these temperature and humidity sensors, which are being spread in the island. And we get continuous readings using the Internet of Things network. Every 15 minutes, we have information about the different these different locations. These locations have been selected with farmers, so we know where are, let's say, the cows or more density of the cows. And well, these are the networking base stations that we get to receive the data. And when it comes to Earth observation, so we already have the temperature and humidity, and this already allows us to provide an alert system, which can be checked on the mobile phone of the farmer. So they will know if temperature and humidity has been reached, and this is based on these sensors. But we are also exploring how the NDVI can also correlate with what's happening in the field. Also, we are exploring some other topics, like how is the actual fields growing in terms of the quality of the pasture, which is ingested by the cows, which can have a very big impact on the quality of the milk. So this is something of a continuous research that we know. And here in the Azores, we have a big issue, which is the clouds. We have clouds all the time. So Earth observation from satellite is a big challenge. Also, heat stress is a major important factor here, because heat stress will have a significant impact on the fertility of cows. And this can also be using these sensors from temperature and also from satellite data. We can also use this information. So we are exploring, besides this temperature and humidity, we are also exploring other variables. And this is just an example of what can be done with Sentinel-2 and DVI, and you can see here some clouds, and we can see the evolution of the NDVI. So this is a relatively high resolution. This is what you have for free available in the market. And of course, we also try to explore other sources of data for NDVI, like the MODIS products, which are products generated by other satellites. And here we have just an example of the Terceira Island and how NDVI changes in time across the year. And you can see some, let's say, hotspots of higher NDVI. So what we're doing now is we are doing correlations and trying to identify how are these variables, and if these variables are all connected or in a way connected. So as of today, this application is first version of the software is working. So there are already alerts being sent to farmers, and there is a real-time risk map. But also we have the support from the local regional veterinary, which is basically for the different locations where we see fit. They will go there and they will collect grass and make the spores counts. So they bring it to the lab, they do the counting of the spores, and we have a cross-validation of in situ data with actually what's going on. And this would allow us to have an accurate map, and of course will give confidence to farmers that the system is really working. So this is it. The project is going on, will continue. within the next 1 year and a half. And as I said, we are starting here in Terceira, and we would like that we also implement this in São Miguel. Of course, there are cows also in other islands, but at least these are the two major production islands in which we are addressing this challenge. And I hope that this was interesting.
Thank you, Pedro. It was indeed very interesting. I think you have addressed the two very important topics also for farmers, and that they, place great hope where technology can assist. You mentioned pest control. Pest control is probably a transversal problem to any crop, and I think it was also very, very interesting how you then try to link this control to the nutritional value of, in this case, is milk. But this is also something that it's very debatable, and looking for more science, that when we have better control, more sustainable practices, actually we are producing better food, better, more nutrients. So I think that was a very interesting perspective. So just to clarify, so you have found that there is a correlation in terms of temperature and humidity with Pithomyces, correct?
Yes.
So how do you actually measure the number of Pithomyces? I don't know if they are a bacteria or I don't know which category do they
Fungus.
fit. Fungus, thank you. How do you measure the actual existence of this fungus with all the monitoring that you are doing? Temperature, humidity, NDVA and the heat pressure, but how do you know that the fungus is actually there?
Yeah, so basically the fungus develops very close to the ground. So what happens is when the cow eats very close to the ground is when it actually is eating the spores of the fungus, and this, when this happens, is of course when you start after a couple of days you start understanding that the cow is not well. Well, actually, it might not be days. It might be maybe 1 month or even more, because there is a cumulative effect, and the liver is, let's say, slowly being destroyed with this. And what we do is we have this temperature and humidity that we know that above this threshold, it will grow very fast, this fungus. And therefore, when the humidity and temperature is above a certain threshold, we actually have people that are actually farmers and also veterinarians from Unicol that actually go there and they pick a sample from the soil and from the grass. And then this goes to the lab, and in the lab they will actually count the spores. So we actually have a cross correlation between the measurements and the environmental factors. And this was something that was discovered by a researcher here from the Universidade dos Açores that actually made the publications, and then at the time it was that there was a lot of programs that tried to teach farmers that this was a big issue and that they had to be careful, but there is no active monitoring program whatsoever. So they are blind, and every year they hear that there's a problem, that someone had a problem, and everybody starts to put zinc on the food. And of course, this is not the way to go. It's not a precision agriculture, let's say.
Okay, so if I understand correctly, the system is still learning how to actually detect that the fungus is actually there, so that we can have more targeted interventions and just stop this spraying zinc towards every single animal. Correct?
Exactly.
That's great. Pedro, just before I turn to our audience, I just wanted to hear your views on that. So you have presented a great project, and we can really see the value that this project has for farmers. What we see often from, these very scientific projects is that sometimes, although they are very useful, is when they reach the end, there's no more funding, so the project has to be dropped. So what are the pain points to make sure that this technology really reaches every single farmer?
Yeah, well, we know that that's a concern that we have since the beginning, and that's why we have included Unicol, which is a company that has private interests in giving services to its associates. Unicol is an organization here that has basically all farmers. So not all, but the majority of milk producers here in the Azores, in Terceira. So therefore, they have an interest, a private interest in ensuring that the system, if it actually works, which we are pretty clear for what we have been able to see so far, will be interested in continuing the service. So this is what's happening on one hand. On the other hand, we have people from Unicol and also from the Air Center at the locations where farmers go with the cows to take the milk, and there are, I don't know, maybe like more than 40 locations of these where the milk is collected, and we have a person there talking with the farmer and explaining to him that there's this system. So we are very close to the farmer, explaining him how the system works. We will have dedicated workshops. We will go to the farmers, and also the team from Unicol. They have lots of technicians in the field, which are explaining how the solution and how the software, how the system works. And nowadays, all these farmers, they have mobile phones. So it's really a very simple application that you can just click on the button. You see the map of Terceira, and you see the different locations where there are different alerts with red, green, orange, and so on.
Okay, fantastic. Have you considered to take this project to other pests? For example, the previous Pedro just mentioned about India, and we know that huge olive orchards or almond groves. There are some specific pests towards these crops. Have you considered using the same sort of technology and measurements to other applications?
I mean, we know that, this is a very specific problem from the Azores region. And that's why we decided that on top of this basic, let's say, main problem, we would like to explore other different layers of services that could be provided. One of them is the heat stress, and it's relatively easy to compute this heat stress index. Cows, when it reaches 22 or 21 degrees, for them is like for humans 40 something degrees. So and this is a problem. And farmers, they will need to take the cows to a different location where it's much better for them. So this is an example of type of services that can be provided. Of course, one of the more interesting ones is the management of the pasture, to see what are the actual to monitor how it is growing, and then to support the management of the pastures. This is the one that we think that could be explored more widely and globally, let's say. And this is to answer that right now we don't have an activity where we are already doing that, but we would like, as soon as we have results, to of course, to explore this elsewhere besides the Azores, if I understood your question.
Yes, fantastic. And just a clarification, so Air Center, in terms of your business model, so you also, as Hidromod, for example, you also work to develop the technology to sell to others, to then sell services to farmers, or how does it work?
Yes, so the Air Center is a non-profit organization. Of course, we want to make services. We always try to find partners from industry, from universities, and from the different stakeholders that can take the project in the future. So we act like an orchestrator that develops first prototypes and shows the value, and immediately organizations and private entities see the benefit of it, and then we transfer this technology to these organizations so that they can keep on using it. Of course, that does not prevent us to host the system for some time, and even to have some sub-products that are more interesting for us and not so interesting for the others, and continue to have them with us. So we are open in that sense, but we are more of an orchestrator of putting together, identifying needs, and above all, accelerating technology. This is also what the Air Center is about: accelerating the use and the uptake of technology to solve problems which are related, in this particular case, precision agriculture, that is towards a more sustainable development, sustainable future.
And we are definitely in need of that acceleration. Things are really getting very, very difficult, so to say. So it's great that the work that you've been doing. Pedro, you mentioned clouds, and we have a question about the clouds. The famous the clouds and the cows at Azores. I think it was even funny when you mentioned the heat problems in Azores. I didn't know that exist, but you very clearly explained that for cows, the maximum heat is slightly below ours. And so the question is how do you get around the problem of clouds in analyzing satellite images?
Yes. So the way that we are looking at it right now is every single bit of information that we can extract out of the satellite we use. So even if you have, let's say, a partially covered island, there will be a small spot from some location in the island that we will try to use it. And so, of course, there are times of the year in which it's much more difficult, and especially in some regions of the island. When you go to the borders of the island, typically they are less covered with clouds. So it's indeed a real challenge. It's a very big challenge that we have, and for the moment, it remains still to be seen how much information we can really extract here in the Azores for this particular project. We had some examples in the presentation where you can extract some days in which you can actually get some NVDI. So this is an example throughout 2018 and 2019. In days in which you really have low or lower cloud coverage. So it's about really spotting the opportunities when there are no clouds and extracting what you can out of it. This is the approach for the moment that we are using.
Okay, this is still a technology challenge to be overcome. This is how we can see through clouds.
Well, there is a limit to what technology can do, and in this particular case, and DVI, in which you are dependent on certain wavelengths that you need to observe, you cannot overcome that without a clear sky. Mm-hmm. So maybe there are other technologies like, for instance, drones, UAVs flying, which is already today used. Many applications use already UAVs, small UAVs and small drones. And these, of course, will provide you with very high resolution, and they can be used as a complement to this.
Okay, fantastic. So we need to work around the limitations of technologies. Pedro, thank you very much. We need to move on, and by talking about clouds, we'll move to Tomas Norton, which is probably very familiar with Klaus, being in Belgium. So let me just quickly introduce you to Tomas. Tomas is a tenure-track assistant professor in precision livestock farming. He is based in the division of animal and human and health engineering. So it's the group of M3 Biors at the University of Leuven. He holds a PhD in biosystems engineering from University College Dublin in Ireland. His current research focuses on precision livestock farming applications, focusing on modeling and monitoring of animal responses to their environment. He is a PI and a co-PI on collaborative national and international projects funded by the Belgian government, Horizon 2020, and the US. He's also an author and a co-author of 87 publications, participating in 53 conference proceedings, 10 book chapters, and is also a co-editor of one book. He has given over 30 keynotes, invited presentations on his research. Currently, he is coordinating of courses on measuring, modeling, and managing bioresponses and sustainable precision livestock farming. And since 2018, Tomas is chair of Section 2 of International Commission of Agriculture and Biosystems Engineering. He also acts as editor-in-chief at Elsevier Journal, Computers and Electronics in Agriculture. He is a series editor for the upcoming Springer Nature book series, Smart Animal Production, and Springer Nature Encyclopedia of Smart Agriculture Technologies. So if you have interesting work, probably you can send it to Tomas, who is probably the one who tell you if you're up to a publication or not. Tomas, thank you so much for being here with us. I now handle the floor to you. Thank you.
Okay, thanks, Claudia. Very fine, I suppose, Claudia. Yes. Okay.
Yes.
So first of all, I want to say thank you very much for the invitation and the opportunity to speak to this webinar. Thanks also for the introduction. I probably gave the full story. Maybe we could have shortened it a bit for this webinar, but okay. Thank you very much for that, Claudia. So I'm going to switch the topic a little bit. So I'm first of all not going to talk about satellite imaging. And the reason is because I'm talking about precision agriculture applied to pig production. And at the moment, there isn't a lot of outdoor pig production. It's mainly done in indoors, and it's quite intensive. But we're seeing now in Europe that maybe the story will change over the next years. So there can be future applications of satellite. But I hope the story I bring today can be a little bit interesting nonetheless. It'll still focus on the use of cameras and the use of mainly video image processing to interpret the information on the health, well-being and productivity of the pigs. But what I want to start off with is on the topic of precision livestock farming. So, yeah, it's a field that I'm mainly focused on in the Catholic University of Leuven. It can be looked upon as kind of the application of techniques, technologies from process industries. And here we talk about the use of sensors, and not only that, the application of sensors, but the application of the thinking. And here I show a scheme on it's a way of thinking of how to utilize sensor data and combine it with knowledge to make models that run alongside the process, so that any deviation from what we expect is normal can be estimated and then used to monitor the animals and perhaps manage them better. And this kind of scheme, this is what we use in our research group. And we have many PhDs who work on different aspects of this scheme. But we're really the technical people, so we develop the models. We look how to clean and make sense of that data and model it. But we connect to, this is a very, very vital part. We connect with the domain experts, so people on the genetics, nutrition, ecology, physiology, and these people help us put knowledge into the models we develop, and therefore we can rely on them a bit better, and hopefully they can move out into the real farming situation better. And yeah, I always get a question: do we really need this this precision livestock farming? Because farmers are doing a good job as it is, and in fact it is true when it comes to livestock farming that many farmers hold a huge amount of knowledge. They have to deal with a large amount of complexity, but the problem they face is that the industry is consolidating and has been doing for the last number of years. It means they have much more animals to deal with on an individual farm level, and it's becoming increasingly difficult for farmers to get good staff that are willing to handle the animals and also understand the business. And alongside that, the animals are far more efficient, but on the other side, they're more sensitive to challenges. They're less robust than they were in the past. And here I have just showing some of the graphs on the evolution of the industry in different countries. On the left-hand side, this is just showing the number of pigs per farm increasing over the last number of years, and the number of farms decreasing. And this is in Belgium, specifically in Flanders, and the same is in the US and in Australia. So there is this challenge in the sector that, you know, farmers need additional support with technology, and that's why we're there trying to do this. So, and actually this whole field, and I just want to show this graph, this whole field of precision livestock farming has been developing for a large number of years. Back since the 80s, people have been thinking about developing tools so that farmers can be more efficient. There's a lot of patents and a lot of publications, and it's really interesting when you see the growth in patents. You see already here, it's starting in the 1980s, and so the research was a little bit catching up, and maybe it still is catching up, and yeah, since the late 2000s, there's been really a lot of funding coming from Europe, and also recently coming from the US, so it's been pushing it. But when we think of the innovation side, that's really done by the innovators. And I have a very interesting patent that was released back in the 1980s, in 1987, and there's a nice idea where a inventor said, okay, there is a problem with piglets being crushed on a farm, on a pig farm, and it still is a very big problem, this. And the sow will lie down on her piglets unknowingly, and she will crush the piglets, and it's always been a problem. But his idea was, okay, as soon as the sow lies down on the piglet, let's detect the screams of the piglet with a microphone, and then try and stimulate via an electric shock the sow to stand up again. So back in 1987, that patent was already published, but you have to add 30 years before a company in America went ahead with this idea. And I suppose at the time in 1987, it was quite challenging to realize this technical idea on a farm, and given you have different components. And also, we have to think the farming community are quite conservative. So farmers adopting technology, it isn't an easy path, put it that way. And yeah, that's why you see a lot of patents and a lot of innovative ideas from the publication side, but yeah, it's not being adopted as quickly as we would hope. But I'll give you some examples of some solutions that are have reached it to the market and are looking to be a success. One of these, it's not using images, of course, it's using microphones, but this is an application of sound monitoring in pig barns. And the idea here is to detect the coughing of the pigs using the microphone. And this was a collaboration that was started back in 2000 and the early 2000s with the University of Milan. And yeah, the main focus is to try and reduce the use of antibiotics by detecting as early as possible the coughing, then sending an alarm to the farmer and to the vet so they can treat early and not only detect the cough itself, but also whether this cough is a sick cough or a healthy cough. A healthy cough can happen when the pigs are just waking up like us all in the morning time and they want to clear their lungs. So it's better to pick out the sick coughs. And then this solution, quite recently made it quite successfully into the marketplace. This is the current hardware. It's combining not only the sound, it's not capturing the sound data, but it's combining it with the climate information, and it's sending then the information to the farmer and to the veterinarian to tell them if there's a problem in the house. So that's already a solution that's on the marketplace. Another area where the technology has been progressing is in weighing of animals. So over the last number of years, we've seen the use of camera technology to extract parameters related to the geometry of the pig and link these with the weight of a pig as a pig is growing in the pig barn. The idea being that the farmer can then identify the pigs that are ready to go to the market and then move those animals out. Initially, 2D cameras were used and were reasonably successful, but there was challenges when it came to illumination, and still 2D cameras are quite useful, but to extract these geometrical parameters, recently the movement in the scientific world at least has been towards 3D cameras. Some of this technology has been moved into the marketplace and it's still evolving. So we're seeing more accuracy by moving in this direction. The big challenges with these solutions is that the pig needs to be in a fixed position in the pen. And we started to work in the research team back 8 or so years ago on the idea to try and not restrict the pig in the pen, but to detect the pig and then try and estimate the weight of the pig while it's freely moving in a pen. And the idea behind that is, well, then if we can estimate the weight, we can also estimate the movement and activity levels and maybe link it with energy expenditure. This kind of evolution is perhaps where things might end up in the end, but this is moving beyond what's available currently on the marketplace. Okay, and recently another evolution is behavior monitoring as a pure application on its own, and a couple of companies have come out with technology based on AI to track the movement of the pigs. Generally, it's on a group scale because understanding what the pig is, identifying the pig and understanding its behavior and so on an individual level can be still quite challenging. And indeed, that's still more or less in the research, still in research at the moment. And it's really at the focus of our research team. So our research team is looking at pig behavior monitoring and really trying to bring it to the next levels beyond what is possible in the industry. The focus is trying to improve the health and welfare of the pigs. And we want to start identifying the pigs, locating those pigs in the pen, locating where the behavior is of interest is happening in the pen, the frequency of these behaviors, and whether these behaviors are linked with indicators of health and welfare. and continue to do this over time on a long-term basis. So that's our big challenge, this 24/7 monitoring of pigs. Why do we do this? Well, we want to look to the individual behaviors of the pigs, the eating, drinking, lying, standing, the interactions, the social interactions, and then move this knowledge into decision support for the farmer. So that's our idea overall. And I'll give some example of the research projects that we are doing. So this is this example that I'll give you now is about tail biting of pigs. Tail biting is a really serious problem in the sector. It causes a lot of loss when it comes to the pigs going to the slaughterhouse because carcasses are rejected. And it's becoming a bigger problem because in Europe there will be a restriction in terms of the docking of tails, the cutting off of tails when pigs are young, and that's what farmers do in order to avoid this tail biting from occurring. So we need to be able to detect the risk of a tail bite event occurring in the barn, and then advise the farmer how to act on that information. So we want to, well, from our perspective, we want to be able to detect, first of all, tail biting events using the video analysis. And this is just one example of one pig biting another pig. And this is happening all the time in the pen. And of course, a person can't be there watching this continuously. So we want to be able to use the image analysis to do this. And in the group and led by my postdoc, he mainly led the development of this pipeline, which detects the pigs, then tracks individual pigs for a few seconds while they're involved in this interaction, and then classifies the interaction itself. So whether it's a tail biting event or not. And this is just the starting point of a bigger project. So we were able to develop an algorithm that worked at detecting the tail biting behavior. But now we're working together with researchers in Ireland and in Denmark to bring this forward into a tool to detect the risk of tail biting events occurring in the barn, and then linking it with some advice that we can tell the farmer. And then, this advice comes through the interventions that the farmer can give. And basically, what I'm showing on the right-hand side here is the type of tool that we are developing for pig farmers. So we're measuring using the image system drinking, feeding behavior, aggression, and enrichment, and we're also detecting the tail biting events. And we're telling the farmer the risk of tail biting, and then giving some suggestions for how he might intervene to reduce that risk. We're doing development in terms of the technology for monitoring, so the camera system, that's what we're working on, and also Aarhus are working on the risk factors. And then there will be some demonstration at the end of this project. So that's how we're moving this forward, and hopefully we can move it at some stage into the hands of the farmers also. Another application of image analysis, this is looking at the gait of gilts, which are young sows, so that a farmer can keep the sows who are walking in a correct way on his farm and reject the others. And we're trying to do this objectively by tracking the skeleton and tracking the movement of pattern of these sows. And we do this in collaboration with PIC, a pig breeding company. And the idea was just this, very simply show you what we're doing. We're tracking the motion of all of these sows as they move past a certain area. And then we're extracting parameters from the skeleton that we followed. And for instance, we take features out of that, like the angle between the front legs and the angle between the back legs, and how these angles vary over time. And then we link it with the gate score. So there's already some gate scores. 5 is poor, and all the way to 7 is, well, 5 is mid-range and 7 is very poor. And then, so we're looking at leg angles, but we're also looking at how the animal is moving over time. And we're linking these parameters with the leg scores. So that's what we're doing in collaboration with PIC. We're also working on applications of trying to monitor physiology remotely. So not just the behavior patterns, but trying to extract information on heart rate and respiration rate. We're using an approach, maybe it's not so clear here, but we're using an approach that's extracting information on the brightness of the pixel and the changing in this intensity of the pixel, and extracting the heart rate from this pixel brightness. And it's possible when you get to the right area of the pig, you need to choose this region of interest very carefully. And once you do that and extract the noise, you can get to the heart rate. And of course, this is still in an early stage of development, because there's a lot of artifacts that creep in when the pig moves and when the lighting around the animal changes, but it's still showing potential that could be there in the future. Another area is the respiration rate monitoring. So we're looking to monitor these pigs, how they're breathing, and also then link that with, for instance, heat stress, and even if there is an infection. And again, with image analysis, we're doing that. And here's an example. So here we detect the pigs, we draw a bounding box, and then we just identify the edges of the pig. And here, you might see the pig is moving, but you can barely see it by eye. But of course, when you process the images, you can see that this will move, and you can extract an indicator linked with the respiration rate. And then we're hoping that this can also extend the application of the camera technology in the pig pen. So then the idea with all of this is that you have one solution, a camera, which can monitor the behavior, it can monitor physiological parameters, and within one tool, you can give the farmer a lot of information, and that's the end game of what we're trying to do. So for us, because we're really working on an applied level, so our research team tries to generate solutions that in the end will reach the farmer. So we try to make sure what we're working on, it gives value to at least some stakeholder, like a breeding company, like a pharmaceutical company or a feed company. And we try then to work hand in hand with them, because then we're sure that the return on investment is likely there because they're involved. And in the end, we also need to collaborate too with the farmer to make sure what the tool is that he really needs. Is it an early warning system? Is it something that he really needs advice, like a decision support system? And at the end, the key thing is the business model for the farmer. And that for us is a real challenge, because we don't work on business models. We need to rely on the company. But we need to make sure the farmer is incentivized to pick up this technology. And typically when we work on from the perspective of productivity and efficiency, then the arguments are stronger. The arguments are less stronger when we work on welfare, of course. So although it's an important societal challenge. And one thing we should avoid, and I think that's why we need to work hand in hand together in big collaborations, is really to get these tools interacting with each other and avoid that farmers need an app for every single application. And the only way we can tackle this is by ensuring that a technology like a camera can be exploited for different different functions, and hopefully then all the information can be integrated and presented to the farmer. So that's one way, but for sure we need to get this integration working across the sector. Okay, to sum up, I'd just like to say that the field is growing rapidly. There's a lot of new technologies coming on the market, a lot of new ideas from the research side. The big challenge is taking it really to the hands of the farmer, because we're developing on a research level these tools, but to really demonstrate the return on investment, it takes a lot of validation, it takes a lot of demonstration, and it's a real valley of, they call it value of debt, because this needs funding, and it's not exciting research, so it's very difficult to convince people to fund this. And that's where the big issue is when it comes to taking this onto the farm. And that's why I say we need collaboration, and we need to really work together with industry, research institutes, and that's why it's very interesting to see the presenters before, how they're able to enable this kind of research and then pass the solution to perhaps another company who will sell the service to the farmer. I think it's a very interesting concept. Okay, with that, I'd like to thank you for listening, and of course, if you have questions, feel free to ask.
Tomas, thank you so much. This was a very interesting presentation. I didn't know that we could monitor pigs in so many ways, and I think you brought very, very interesting topics. You mentioned the question of intensification of the pig farms, concentration in terms of the commercial challenge. You also mentioned that farmers are conservative by nature, and we fully understand why, because get one technology, get it wrong, and you have the entire production destroyed. So the margins for errors are very, very small. You mentioned business models and the need that we have to have the business side of our technology in mind. You also mentioned how don't overload, the farmer with loads of technologies, loads of sensors, because it's just it's just going to confuse everyone. And in the meanwhile, you were presenting us with very interesting challenges at the farm level and the possibilities with monitoring. And I think the use of sounds probably is one of the signals that is one of the most challenging in terms of capture data, but actually can give us a lot of signs. One of the things that we are in danger we do first is to scream. Exactly. So it's very, very interesting. Just one question, because we are slightly out of time. You throughout your examples, we could see a lot of efficiency in the farm being addressed. How could you use your research, your precision livestock farming, to apply more sustainable practices at the farm level? And this is also a business model that probably will come up with all the EU regulations and a lot of indicators that need to take into consideration the environment. Do you also have this dimension on your research?
So to start off, I would say that most of the work that we do is with the focus that we can work on a scale, and that therefore we tend to look to the current commercial systems, because the reason is when it comes to new alternative systems to improve sustainability, there's a vast number of different options and different ideas, and it seems like there's a lot of ideas emerging how to, for instance, farrowing of sows, different designs of the crates so that it's more sustainable, more welfare friendly, reduces emissions, and different housing concepts as well. But the big challenge is these are still concepts. So when it comes to developing tools to enable farmers to optimize their system or to improve their welfare, it's very big risk to just go with one of these options in the hope that in the future some farmers will take it up, and in the end they may never take it up, and your ideas are then stuck with research. So our way of working at the moment is to look to the commercial farm to see what are the big challenges in terms of welfare and feed efficiency and health, and try and help the farmers make the most of what they have. And then in the future, we'll have to look towards really what are the systems that Europe or the different countries are going to take up and are really bringing to the farmers so that they have to adopt it. Yeah, it'd be either pushed by a supply chain or by the government that there should be certain adoption of systems for more sustainability targets, and then we'll get involved in those systems. But until then, we have to work on more commercial scale farms, or larger scale intensive farms, I would say. I don't know, is that answering your question, Claudia?
No, that was a great perspective, and in fact, probably for some farmers, the environment is already a pressing issue, because it's really affecting productivity and profits. Probably here at least at big farms level, probably that's not such a huge pressure yet, but it will probably come, and then will turn out to be an economic problem, and then we need to find the solutions quickly. Thank you so much, Tomas, for that. Tomas, I have a couple of questions here. In your opinion, can this technology be used to monitor animal welfare and help in certification processes?
Yeah, I think that's what we should aim for with the technology. Animal welfare, it's becoming more and more of a challenge or more of an interest in Europe, because it's one way that Europe can separate its meat products from the rest of the world. When you look to the US, when you look to the south of America, there is very little focus on animal welfare, but we have been doing animal welfare to a high level in Europe for many years. And when the big problem is proving that. So there's two ways. Either you send an assessor into the barn and you ask them to score the welfare. You pay a lot of money for that, because it should be done regularly and objectively, and that's the objectiveness of a human observation is also another challenge. But when you do it using camera solution or others derive the information on welfare from other sensors, it's more objective, and then it can also be implemented at scale and continuously. And I think that's the advantage that we can bring it to the table. And that information can also then be linked with labels of welfare and used in the supermarkets to separate products. And I think then, we can have a stronger influence on people's choices of what they eat. I also think we can then position the livestock sector a bit better than it is at the moment, because the perception in society by the public is that animals are mistreated, they're just treated as machines. But oftentimes, if you go to a farm, you'll find a very good farmer. He understands his animals very well. The problem is he can't get that message out there. But at least I think and I hope that through this kind of technology, the quantitative objective information can go at least to the people then who can use that information, like the packing plants and the supermarkets, who can then integrate it into a label and help differentiate the products on the shelves. I hope there's a future there for that.
the consumer is always key in all these changes, to make sure that they have the information and they make the informed decisions towards this their choices. Thomas, one more question from Pedro. What are the clouds of peak detection? What are the clouds of peak detection?
The clouds.
Pedro, the clouds, Pedro,
So, yeah.
are you?
What I mean, so we were talking about satellites, and one of the questions that was arose before is how we solve the clouds in the when we are looking at the satellite images, and so and this is, it seems like almost funny, but it is in fact to make one of the things that we are pressing here in this webinar is how we make this affordable for the and usable for the farmers. And one of the things is the whatever makes some noise in what we are measuring. And in the case of satellites is the clouds. In your case, I was looking at those images and I was thinking that if you would put like a white, if everything would be white, it would be more easy to detect everything when you are measuring. And with the sounds, if everything was silent, then it would be better than noisy. And so
Pedro, we every day we suffer with the clouds. we're suffering. But I think it's also what it makes it interesting, of course. But the variability between farms is a big challenge. For instance, in the pig sector, you have some floors allow the manure to go through, whereas other floor is solid and we have straw material on the floor. And then you have, the pigs are moving, the straw is moving, we have to separate one from the other. These are challenges that are introduced. Also, when you think about it, the farmer needs to, at the end of a batch of pigs, he needs to clean out his house. You need a camera that needs to be robust to this, and that needs to be able to withstand it, of course. And then over time, you have issues like sometimes you have to ask the question, am I tracking pigs or am I tracking flies? Because the flies are landing on the lens. And these things, and you have to pick your moments then that you can do something useful. So even though it might look straightforward because you're inside, because it's a livestock environment, you have a lot of challenges that creep in.
Thank you for the clarification, Pedro. I wasn't really seeing the clouds. We're just about to close, and I just want one final question for the three of you. So as you know, we are also applied research, a collaborative laboratory. So what do you think what role could we play as Food for Sustainability to assist you to make your technologies more ready for the farmers? So what role do you think we could play? We mentioned closer to farmers, more dissemination. For example, Thomas, Pedro at the Source has this wonderful project of vacas felizes, the happy cows, just to note that it's true that we're not aware that farmers actually really care for their animals and their crops. So where do you think the synergies should come, and who should do a little bit more work, or aren't we communicating enough? What are your thoughts?
Well, my opinion is that you are very close to the farmers. You are in Beira Interior, where there is a lot of farmers needing of all this information. And I think all the connection that you can make showing our things to the farmers and teaching them to use this kind of information, it is a very valuable information, and we cannot do it. I cannot do it because I'm in Lisbon, or at least not as easy as you. Pedro Silva is also in Açores. He can only go to the farmers there, but he cannot go to the farmers in Beira Interior. And Thomas will love to come here on vacation, but he cannot speak with the pig farmers in Beira Interior. And so I would think, I would say that you have a very big role in talking with the farmers and teaching them to use these things.
Okay.
I didn't want to speak by the others.
Yeah, well, we'll probably also need to report more, maybe also to you. Pedro. Do you have?
Yeah, well, I
Yes,
think
Thomas,
that-
go ahead.
go ahead.
Yeah, no, but I agree completely with what Pedro said. I think it's a limitation that, yeah, oftentimes the farmers, when we say what we're doing, they're looking up to the sky and they're saying, "What the hell are these guys at now?" It's yeah, but yeah, I think we need to connect with the farmers, and we need someone to act as that conduit. But another thing I think which is really interesting is the connection of different stakeholders to bring a solution to the end. We have a part to play in the university, but when we see where we are and where the final application is, there's people in the middle that we need to work together with. And I think, yeah, defining this network that we can really, what we work on, we can be sure it ends up in the hands of the farmer, is really also something we struggle with. Yeah, I think maybe this defining consortia where we can really be sure that solutions will move it to the market, that's something I'm interested in for sure.
I would say on my behalf, from what I've been able to witness so far, is
Find
that
all pieces of the puzzle to make sure that the puzzle connects.
there's a bit of a delay here.
Yeah.
Apologies, Pedro. It seems that we have a lag.
Yes, I don't know. It's my computer, or well, I don't know.
Go ahead, Pedro.
I think I would say a huge challenge that we see from what I've been able to see so far is we are able to see so many differences between the different locations in Europe and farmers, and from a cultural perspective, there are huge differences, and also the skills that farmers have. I think this is extremely important, and some farmers might be more interested in using technology because they know that the technology and the tools and science can help them have better productions and better. And I think that this is something which is more on the training side of, but also on the culture of having highly skilled people really in farms, and this is a paradigm shift. And here in the Azores, this is also another reality that when we compare to our interior, when we compare to Ireland, to Scotland, to many locations out there, they are very different. And I think that this is the challenge, really, a big challenge, that these tools and these technologies are extremely powerful, but we have to find ways in which farmers can make the best use of this technology, and it can be either through indeed training and and understanding that they are sensitive to this, or it can be very simple basic mechanisms like if I do this, I get that, and that's it, right? So it's basically kind of an economic driven thing, and I don't care about the other things. So this approach implies a different way of communicating, and I think this is a big challenge.
Yes, definitely. We are full of challenges. We have a very important purpose, and so let's us keep talking and keep collaborating, put these topics on the table. Thank you so much for sharing such a brilliant project. Thank you for your time. I hope that our audience has also enjoyed our webinar. I will call this now to an end, just to remind that we'll have 1 week interval, and we'll start on the 23rd of June with functional nutrition. Okay, so thank you so much for being present, and see you in 2 weeks' time. Bye.
Bye-bye.
Right.
Bye. Thank you. Bye.